I think it's probably just 2 of us, so we'll just carry on. I'll put the recording on the channel for anybody that wants to watch it. Okay, so the paper we're looking at today is this, the GEM benchmark, natural language generation, its evaluation and metrics. So in short summary, the problem they're trying to solve is that the current quality of the data sets is not great for languages other than English. There's a very heavy English focus for natural language generation. A lot of the current research is really targeted towards a few benchmarks. And so researchers are really pushing their systems to beat those benchmarks. And because the quality of the data is not fantastic and the quality of the metrics are not fantastic, and people are so focused on the benchmarks, this is kind of skewing the progress in the field because systems are brittle. They may work quite well on the benchmark, but then you apply them in real life and they don't work as well. So what these guys are trying to do now is to kind of say, we want to get away from that single focus on benchmarks. We want to create a living set of data sets. And the idea is that, okay, when they release this, which is fairly recently, and they're going to have another discussion at ACL 2021, but once a year, they will reassess the benchmarks and maybe bring new benchmarks, reassess the data sets, potentially bring new data sets in and remove data sets. And they're also going to have what they call challenger data sets, which is perhaps test-only data sets that they will release every now and then. And the idea is whatever model that you train, you can try it on this new test data set, which it has never seen, to debug your model. So it's not meant to be iterating on the whatever metrics they're reporting, but really, to kind of debug your model to see how well it's doing in on data that it's never seen before. So that's why they've got this notion of that this is a living benchmark, that it's not kind of fixed in stone. It will evolve on a fairly regular basis. And the reason there's so many of these people mentioned in this paper is that basically there's, depending on the different type of text generation task, for instance, there might be a dialogue generation task, there may be a summarization task, there may be a question answering task. Different groups are then responsible for maintaining the data sets and the potential changes in metrics used to evolve it. So that's why there's so many. So later on in this paper, the groups are broken down into who's responsible for what. That's why there's so many people kind of mentioned on here. So that's kind of the summary of what they're trying to do. So so this first iteration of it in the paper, they're going to describe a whole set of data sets, which they as the first iteration of the data sets. There's still quite a lot of English, but they also introduce quite a few multilingual data sets, a few which are totally multilingual, don't involve English at all, which is kind of progress. And then what they're doing is they're kind of defining a whole range of metrics. Some which are not as heavily used. So they've got these notion of now these kind of semantic metrics, which kind of address whether or not the output that you produced is kind of semantically similar to what was expected. So there's a whole range of metrics now that your models can output. The other thing they're doing is that they produce a little tool which kind of allows you to explore the model once it's been run on all this. It gives you a more holistic view of what your model is doing across all these different metrics. So instead of focusing on one particular metric and how you've done with that, it gives you kind of like a more rounded view of it, so that hopefully having that kind of more 360-degree view of the model, you can see its strengths and weaknesses and potential areas where you can improve. So that's kind of like a summary of what these guys are all about. So I think it's worth reading this first paragraph as to what motivated it. So it's okay. So I'm giving here. We introduced GEM, a living benchmark for natural language generation, its evaluation and metrics. Measuring progress in NLG relies heavily on a constantly evolving ecosystem of automated metrics, data sets, and human evaluation standards. However, due to this moving target, new models often still evaluate on divergent, anglocentric corpora with well-established but flawed metrics. This disconnect makes it challenging to identify the limitations of current models and opportunities for progress. Addressing this limitation, GEM provides an environment in which models can easily be applied to a wide set of corpora, and evaluation strategies can be tested. Regular updates to the benchmark will help NLP research become more multilingual and evolve the challenge alongside models. This paper serves as the description of the initial release, for which we are organizing a shared task at our ACL 2021 workshop, and to which we invite the entire NLP community to participate. So a little bit about what is wrong with the current set, flawed metrics, very Anglocentric corpora, brittle models, and what they're hoping to achieve with this. Okay. Now, so one of the things that we want to evaluate models on are the text. So the generated text should, these texts aim to fulfill an underlying communicative goal, for example, to produce a summary of an article while remaining faithful to the input information, fluent, grammatical, and natural looking. So a few of these are very tricky to judge. For instance, faithful, which is semantically what you want essentially. Fluent and grammatical, again, tricky, currently involves a human kind of evaluation, and natural looking. So this is the kind of challenge that future model makers are wanting to be addressed. And then they say, finally, it is often desired that repeated interactions with the model produce diverse outputs, for example, to explain concepts in multiple ways or to become a more interesting conversational agent. All these optimization objectives can often be conflicting, and as a result, evaluations that focus only on a single aspect may fail to recognize the drawbacks of a particular method. So they're obviously challenging the community to make the models more diverse, rather than input-output, where the output is very heavily conditioned on the input to make it more stochastic and more diverse, so that the agents produce a much richer set of outputs. So some of these are kind of aspirations. There are systems already kind of looking at this. For instance, this paper, the 2019 paper. But yeah, so it's a really interesting kind of challenge that they've set themselves. So they've got a little discussion here about what's wrong with the current metrics. So Rouge is one of the popular ones that's used. And Rouge basically is to do with the intersection of what you produce compared to what was the target. So you get a higher score if there's more kind of intersection in terms of the n-grams between what you produced and what was the required. But the problem is that has the perverse effect that if you produce a longer output, then that's highly likely to increase your Rouge score, because you've just produced more information which the intersection can apply on. So they say, since Rouge only tests the extent to which a generated summary has a lexical overlap with the reference summary, it can erroneously produce high scores for fluent yet meaningless and unfulfilled outputs as long as many of the same words are used. Moreover, Rouge tends to favor systems that produce longer summaries. So they've got a little discussion about some of the current metrics and what's wrong with them. And then they've got a little bit about human evaluations. Moreover, while human evaluation generated text can provide complementary insights to automatic evaluation, it can also lead to contradicting results, since studies often omit crucial replication details and assume different definitions of the measured quantities. So essentially here they're saying is that each individual study where there's some human involved in some evaluation, unless we standardize in some way how humans evaluate that, then you cannot compare what one person's results are to another person, because they may have completely different, they may have instructed the humans in how to evaluate in a completely different way. So again, there's this issue with replicating people's results and comparing results. So this is now what they're proposing. So we propose a living benchmark called GEM, Generation, Evaluation, and Metrics. So that's what GEM stands for. That aims to enable research on a wide variety of NLP challenges. To avoid the fallacy of encouraging hill climbing on the leaderboard, GEM focuses on an in-depth evaluation of model outputs across human and automatic evaluation that aims to uncover shortcomings and opportunities for progress. As datasets, metrics, and models improve, the benchmark environment will improve as well, replacing solved tasks with more challenging ones, incorporating newly developed metrics and addressing discovered flaws in the experimental setup. as demonstrated in Figure 1. Making all model outputs available under an open source license for supporting evaluation research and integrating new metrics will in turn help their adoption and increase the robustness of model evaluation. I'll just read a little bit more before I show you the diagram they just mentioned. So the initial set of 11 included data sets is presented in Table 1, and we'll just have a look at that. So there's 11 included data sets in this release of this paper. They measure specific generation challenges such as content selection and planning, surface realization, paraphrasing, simplification, and others. In addition to those challenges, GEM datasets also differ in their communicative goals, languages, the noisiness of data, and resource availability to evaluate the consistency of evaluation schemes. About half of the datasets have multiple references, and more than half are post-processed to improve data quality. The size ranges from 5K to 500K data points. So this is kind of the wheel that they hope, virtuous kind of cycle that they hope that this, approach is going to do, which is you have improving metrics. Sorry, if we start with improving data, improving models, consistent human evaluation, improving metrics, and then you go around the cycle again, improving data, improving models, improvements in each section, as I say, improve the quality of the overall outputs. I don't know if you had any questions so far. I know I've rambled on a bit. Yeah.
It makes sense so far.
Yeah. So far it's all quite high level, kind of aspirational kind of stuff about what they want to achieve. And the first initial release of it, what data sets and what metrics they're going to have. So let's have a little look. So what they've also done is that they've really documented the data sets in quite a consistent way. So to ensure that research with GEM is conducted responsibly, all the data sets are documented in NLG's specific version of data cards we developed and for which we release a template and guide. Yeah, so Emily Bender is quite famous. There's been a lot of controversy actually about some paper that she's written to do with large language models and their bias and a lot of other issues to do with how responsible they are and how much energy they take to train. So yeah, she's quite active in this area. Okay, so we got benchmarks and analogy. So okay, so these are the data sets that they implement. So they're worth having a little look at. So first is Common Gen. This is an English data set, produces a likely sentence which mentions all of the source concepts. So this is quite interesting. So it puts in some source concepts, and the output is a sentence which mentions all of those in a fluent set, and that's 67K size. Second is a Czech restaurant produces a text expressing the given intent and covering the specific attributes. So meaning representation. So the text, a lot of those I've seen is where the text produces something like, this is a great restaurant with tasty French food and not too expensive. So that's sort of the output that gets. So a dart, so it describes cells in a table covering all information provided in triples. So this is interesting. So this is some kind of a tabular data set being used to do something. I've not heard of that one before. End-to-end clean, describe the restaurant, given all and only the attributes specified on the input. So that's very similar to the Czech restaurant one. ML sum, summarize relevant points within a news article. And interestingly, this is a German and Spanish data set only. Schema guided dialogue provides surface realization for a virtual assistant. So that's quite interesting. I think I read that one. I think we, in one of the previous sessions, the Vestogi paper. Okay, total, which is produced an English sentence that describes the highlighted cells in the context of the given table. So it's kind of table to text. Xsum, find the relevant points in a news article. Web energy, produce text that verbalize the input triples in a grammatical and natural way. Yeah, that's English and Russian. And then Wiki Auto and Turk Assist asset to make the same information in the source sentence using simpler words and grammar. That's an English one, and then Wikilingual produces high quality summaries of an instructional article, and that's across quite a few languages. English, Spanish, Russian, I guess there's Turkish, and that might be Vietnamese. So yeah, quite nice, kind of varied collection of data sets. A few of them I'm quite interested in because they're kind of the schema guided one, as I've already seen, a couple of the other ones where there's kind of constrained text generation, which has to be semantically consistent and relevant. I don't know if you had any comments on any of these data sets. I mean, I'm sure we neither of us have really seen any of them in action.
Yeah, I think we have like encountered some of these tasks before. And probably data sets are, or some of the data sets are connected to the papers we read before.
Yep. Okay, so this is now a little discussion on why they moved away from doing a single kind of leaderboard and what the problems with that are. So it says, however, they also pose a risk that progress is reduced to a single number shown in a benchmarks leaderboard, and thus may encourage blindly optimizing it without account for other considerations like model size or fairness. This is especially challenging for benchmarks in NLG, since as discussed above, the performance cannot be described through a single metric, which is often not clear what metric to optimize for. This shortfall can be seen in benchmarks like DECA NLP and GLGE, which include NLG tasks but focus only on a single metric, and as a result may mischaracterize the system's performance. Moreover, an easy-to-use data infrastructure also disincentivizes researchers from interacting and conducting in-depth analysis of the data sets that models are trained on. Yeah, so I mean, if people really become familiar with one particular data set which they're working on with their model, then you can get very narrow focus. So it's interesting that they're saying this is one of the side effects of having a leaderboard that people get really kind of hooked on. And then carrying on, they're saying these changes emphasize selecting data sets for a benchmark needs to be carefully done, that the setup has to remain flexible to be able to address newly found limitations, and then the benchmark should focus on climbing the leaderboard. Instead of a living benchmark that can adjust its data sets and specific evaluation can be much more powerful and long-lived. This can, for example, be seen in Dynabench, which has a static evaluation but interactively adds more test data through a human-in-the-loop approach. Yeah, so this is kind of an evolving data set there. The other aspect is increasing multilingualism. This is a specific aim of this approach, is to ensure that this research doesn't remain too kind of English central. So they've included data sets that are multilingual. Description of that. And then the evaluation of these models. So they say most traditional automated metrics such as Rouge and Blue measure the n-graph overlap between reference and the generated text. However, in most cases, there is more than one correct way to generate text, especially in tasks with a latent content planning or selection step. That means that a correct solution may score low on a metric, while multiple references alleviate the issue somewhat. These metrics still have a low correlation with human judgment. So yeah, I mean, we've known that Rouge and Blue are not really good, and a lot of times you need a human in the loop to add in a little bit more validation. So what have they done? So the latest metrics focus on semantic equivalence instead of lexical similarity, which improves the correlations drastically. So yeah, so they're moving away from Rouge and Blue. Not totally moving away, they do give sort of the values for those, but they're adding these new semantic similarity ones, and these are called bird score. I haven't read this paper, I think I might read it. But essentially, what they're doing is, so moreover, Maturital and Pretital find that when comparing to a high quality system, differences according to metric may also stem from how references are written or flaws in the metric itself. Okay.
Yeah, I think this was mentioned in that one of the papers I read on style transfer. And if you remember, they used a couple of big pre-trained text models to evaluate the performance. And I think BERT score is kind of similar to that. They probably, I'm sure they used Roberta, trained for classification, and another model used to evaluate the semantic similarity.
Yep.
It was something, I don't remember its name.
Yeah. Yeah, as you were mentioning, it might have been nice to write summaries of some of these things. So afterwards, I'm going to write a short, like maybe half a page summary of what we've just talked about, so that if we ever need to come back to it. But yeah, I might read that one because I'm quite interested in how their score works. So carrying on this, and given that automated metrics perform differently across tasks, setups, and languages, a multitask NLP benchmark has the opportunity to act as a test bed to evaluate how the latest advances in automated metrics perform on these different tasks. Okay, so there's a multitask benchmark. The benchmark can facilitate this research through the release of system outputs and associated human annotations, which is what we are planning to do with GEM. Moreover, we allow the integration of additional metrics into our living benchmark system, which enables a much faster adoption. Yeah, so adding in additional metrics is explicitly allowed in the system. The other aspect they want to look at is developing reproducible human evaluation standards. So they want to kind of define how to evaluate models by humans, which is everybody's currently kind of done their own thing whenever they've had a human in the loop. There's some papers on, there's a paper with Gini, which seems to be a mechanism to standardize human evaluation. I haven't read that paper, but they're using that as inspiration for their approach to adding in humans into the loop. Okay, so now they're looking at dataset selection. So they're saying, moreover, the dataset should cover a wide range of relevant generation challenges that allow for findings to be as general as possible. Yeah, so I mean, we'll see how good the datasets they currently are, because these are pre-existing datasets, they're not brand new. But I'm guessing that as things move forward, they will add new datasets. Because they're saying basically as soon as systems start doing really well on a dataset, they'll create more challenging data sets instead of sticking with that one and kind of stalling progress, as it were. And then they've got some selection criteria for the data sets. So they're probably they're summarized here. So we focus on diverse high-level tasks over a single high-level task evaluated in depth. However, each high-level task should include multiple data sets. Okay. We focus on clean data sets to avoid conflating model mistakes and then noise. So yeah, so they're doing quite a bit of work on cleaning up the data set. So this is not raw data that's going into these models, which is interesting. We include a mix of high and low resource data sets. So which is interesting because not all languages have like a lot. So they're explicitly kind of mentioning that there will be some low resource data sets. We focus on data with interesting test sets. We should not focus on the quality of current evaluation strategies for a given data set. Okay. We prefer multi-reference data sets, and these have shown to lead to more robust automatic evaluation. Okay. So
what
that's
does
kind of a
multi-reference?
Okay. I'm not sure what they mean by that actually, for multi-reference data set. Unless they're saying that data sets that have already been used by people in a few different situations. So there are papers that use the same data set for summarization, papers that use the same data set for maybe, I don't know, some sort of extraction.
Oh, I see. Yeah, makes sense.
That's my, but that's my understanding, but I haven't looked that up, but that's a good question what they exactly mean by that. Okay, so they have a little discussion about the task that they're going to challenge. The task they will challenge will be included in the task they won't. So they're saying the proposed tasks are summarization, dialogue, simplification, compression, question answering, creative writing, data to text, and question generation. So they don't do anything with images, so they exclude image inputs and question answering, because those tasks add complexity to the evaluation beyond the generated text. Okay, so this is kind of like a strange, well, I mean, they make a point about it. Okay, they're saying we don't want to add in tasks which are really quite difficult for even humans to judge whether or not you've done a good job. Question answering, I'm not sure about, but they're saying, for instance, things like creative generation tasks like story generation, poetry generation, some even more from inadequate evaluation approaches. There was a consensus to not include them. Yes, they don't do creative story or poetry because it's just really difficult to evaluate models on those, even for humans. But these are the most challenging problems, so I don't really agree with it. But yeah.
Yeah, I think just today we had some brief discussion about yeah, it arose from a discussion of tokenization techniques used. So there is this sentence piece approach and like byte pair encoding approach, one which builds like from the like starting with unigrams and then creating larger n-grams, and another one like BERT tokenization, which starts with trying to encode the full words and then splitting those. But yeah, actually this discussion led to, there was like a blog post on GPT-3 results, and one of the flaws of GPT-3 was it has a rather minor advantage over much smaller GPT-2 when, for example, evaluating it on poetry generation. And so what the author of the post claimed that it most probably arises from the fact that this byte pair encoding tokenization makes it really hard for a model to learn this character level relations, because it's quite unstable, and sometimes like or misspelled word which like have very similar meaning, or some words have like different kind of spelling, but it has similar meaning, for example in English and American variants. And so this kind of problems of with understanding what actually this byte pairs mean, it makes it really struggle with this kind of like character level tasks, like creating some one example was it can like produce a good jokes, but on semantic level, not on this like grammatic level, you know. And yeah, another one was poetry. And so this kind of task can reveal some flaws of the models. And so that's like a controversial decision to exclude some tasks because those are found like difficult to evaluate.
Yeah, yeah. No, I totally 100% agree with that. Because I think we'll probably make massive progress once we tackle some of these problems. But yeah, I mean, that may change because this is living. So it might be that a year down the road. But yeah, right now it does seem like strange to take out a few things, which are some of the most difficult and challenging tasks in NLG, just because, yeah, as you say, evaluation's a bit hard. So they've chosen 11 data sets, which we kind of already looked at. They kind of give some of them are small, only 5,000, some quite large, 1.5 million, but most of them are kind of medium-sized. Some of them are not English at all, but there's a reasonable collection of like multilingualness. So the high-level tasks they're doing are dialogue, summarization, data to text, and simplification. So these are the main tasks that they're actually looking at. Okay, so then they have a little bit of a section on gemifying the data. And essentially what this means is cleaning the data up to make sure that it's as clean as possible, well documented. There's a strong understanding of like any biases and things like that, and they kind of then document it in this thing called a gem card for each data set. And so yeah, so the data sets are evaluated to make sure they're suitable before they'll go into any of these models. So they're not like just to Wikipedia data or anything like that. Yeah, they've been pre-assessed as to whether or not they should do it. And then there's a little description about each of the a couple of the main data sets, such as MLSUM and XSUM, which is okay. So there's a schema generation. Okay, yeah, this is just exploration of the data sets and how they may be used in specific kind of tasks. What they've done is to create a baseline models, and I think they're using T5, yeah, T5, BART, and MBART, multilingual BART. I think they might even have used Pegasus. So anyway, a few of these current state-of-the-art models, they've created baselines based on those as part of this paper to kind of get things going. And yeah, so they do Pegasus, Dialog, GPT, so a few different models they've mentioned in here. And they're saying actually all the baselines, you can reproduce them on a GPU collaboratory notebook with 2 to 3 hours. So these are not, because the data sets are not like monstrous sized, virtually all the things can be played with, within a few hours basically, which is quite nice. And then they're looking at the automated evaluation. So the first bit is lexical similarity, which is the blur, the rouge, and the meteors of the world, which is how a lot of the models are currently evaluated, but obviously they have really huge problems. And then they've got this notion of semantic equivalence, which, as I said, I hadn't really explored before, but is really interesting. So it says more recently, metrics that rely on pre-trained language models have shown improved correlation with human judgments on the segment level. We thus include BERT score, a metric based on the similarity of sentence embeddings, and BLERT, a metric that is fine-tuned on human ratings. Okay, so this screen is basically a GUI they produced on top of the models that are submitted to them. And what this is doing is, instead of like having like a single leaderboard, what they've done is for each model, for instance, they've just highlighted T5 there. They've on the left-hand side of the models, and on the right-hand side, they've got different categories of metrics. For instance, descriptive, diversity, factual, lexical, semantic. So these are the different kind of metrics within each of those categories. And then what they do is they plot each of the metrics on the x-axis, and on the y-axis is the score. So what they're saying is, well, this approach is going to stop you from overly fixating on one particular score, like Rouge, and kind of give you how your model is performing across a wide variety of metrics that you have access to. So that, if it's performing particularly poorly on a particular metric, maybe that'll give you some ideas on how to debug it or how to improve it. And the idea that we would quite like is obviously performance improvements across a range of different metrics rather than getting fixated on any one particular one. So this is one of the things that they're kind of touting is one of the main differences in this approach compared to something like Superglue, which is just a single leaderboard. So that was quite interesting. I don't know if you had any comments on that one or any questions.
So their like highlighted line is performance on one particular task, right? The red line. And
the total value.
Have a bunch of tasks here, all plotted in the same axis, right?
Yeah. So I don't know how they normalize them. I mean, because I'm assuming the scoring, well, unless it's always between 0 and 1, I guess, in each of them, because they're all sorts of different metrics there. But I guess you're always interested in increasing every metric to be higher, because I think virtually all of these, higher is better. But yeah. So this is the idea.
Okay. Yeah, and how do you and they do not provide like a way to compare different models?
It doesn't seem to, although I haven't used their application, but that would make sense. You should be able to compare your model against somebody else's model across a whole range of metrics. So I mean they don't mention it, but that would seem an obvious kind of next step, because that might give you an idea of why your model is performing poorly on a particular the metric when somebody else is doing really quite well, because that might give you an idea of how to improve it. So yeah, that's a good point. I didn't see any mention that they would do model versus model comparisons, but it just makes sense that they should do that.
Yeah, true.
Okay, so probing for faithfulness. So this is quite an important problem in NLG. So while not included in this initial release, we want to note another approach that has shown a promise in summarization. The approach relies on the insight that a reader of a reference and a generated summary should be able to answer the same question, regardless of how the summary is phrased. There has been much developed towards these QA-based approaches, IL, Skialum, Dermos, Wang, among others, and they can provide an alternative angle to model evaluation that does not highly correlate with other evaluation approaches. In addition to faithfulness, there have been related efforts to provide more fine-grained and interpretable metrics, for example, to measure consistency in data-to-text problems, or to combine multiple measures such as entanglement and similarities. So, yeah, so they're not including this faithfulness in this release, but this might be something that's coming in, fairly soon, because this is a really interesting problem. Because I mean, if you want to do some diversity in the generated summaries, you still need to be able to evaluate them in some way, and this seems like quite a good approach to be able to evaluate it. So I don't know if you had any questions on this faithfulness. Actually, it's quite important.
Yeah, it makes sense of it, and it's like quite a smart way to evaluate some summarization performance, right?
Yeah. And then the other thing they want is diversity. So as argued by Hashimoto, among many others, NLG models intrinsically trade off diversity and quality. Our model can produce more diverse outputs through sampling, but at the cost of output quality. To account for this aspect, we compute multiple diversity metrics, starting with those proposed for the analysis of the results of the E2A NLG challenge, and by Van Miltenberg. These include the Shannon entropy over unigrams and bytegrams, the mean segmented type token ratio or segment lengths, the ratio of distinct n-grams over the total number of n-grams, and the count of n-grams that only appear once across the entire test app. Yeah, so I don't really understand any of these metrics, but I can understand the problem with diversity. If you want something to be diverse, but you don't have huge amounts of training data in that diversity, then yeah, if you make the model more stochastic, it's going to affect its quality. Some outputs will be better than others. Whereas if the system was going to output one particular output. But yeah, this is an interesting problem. And they've got all these metrics, but they're all quite technical. So I guess they do measure, yeah, kind of how different two outputs are in various ways. But basically, a lot of these metrics they mentioned here, they are including it in the benchmarks that we saw. So some of those entropy and bytegram conditional entropy and all of those guys, they're being output out here as well. So you can see how well your model is doing on diversity.
So, okay, Shannon's entropy is a measure of mutual information. And they measure it on what? On the outputs from the same model on the same task, like they want it to be quite diverse, right?
Yeah. So they've got this thing. These include the Shannon entropy over unigrams and bigrams, the mean segmented type token ratio. Oh, sorry. Yeah, so they're doing the Shannon entropy over unigrams and bigrams only. I don't understand the computation of Shannon entropy, so I can't see how exactly that's computed, but they are reporting on it, yeah, on unigrams and bigrams.
Yeah, I see. Okay.
Yeah, I mean, the important thing is that they're really including diversity as a main metric in this particular approach, because we want systems to be diverse, which makes sense.
Yeah, sure. I remember quite some time ago, or this paper which introduced nuclear sampling, which is based on a word can be sampled based on like top K from top K words, or and this nuclear sampling is basically sampling based on like top probability. Like And in this case, if one word is super probable, it might be only, we are sampling only from one word. But if there are some like 10 words, make that probability, say 90% of the probability, we sample from 10 words. And this was like quite an improvement for natural language generation. And there was this picture which compared like natural text written by humans and text generated by models, and probabilities of the words generated by model were much higher usually than those written by humans. So it means basically that human do it much have much more variation, like much more stochasticity in the text. And basically, yeah, so this human written text would have, I guess, like higher perplexity, but that's actually good. And when we measure the performance of this text generated models, how good the model learned the text, we usually, one of the metrics we rely on is perplexity, but eventually it turns out we don't want the lowest perplexity text to be generated, right?
Yep. That makes sense. Yes. So yeah, that's very interesting. So there's a few of these papers that's related to this now, so I might have to read a couple of them. Okay, so finally, they also characterize the system. So basically, this is kind of like a kind of a description of the number of parameters in the model. Let's see. So the final section of metrics will characterize the systems. While the focus of this section will be on qualitative descriptions through model cards, we also gather quantitative information that is not necessarily associated with a judgment. As part of this, we collect the number of parameters of a system as suggested by Raja and Jarafsky. For each task, we additionally report the vocabulary size of the output and the mean output length of the system. So yeah, so they're creating like a card of info about each system to be able to kind of at a glance see or compare two systems in terms of their size, what vocabulary sizes they deal with, documenting systems. So I mean, it's not super critical, but it's nice that you don't have to hunt around for that information. A lot of this quite important information is is actually created for you. Okay, so finally, results. One of the central aims of GEM is to measure the progress in NLG without misrepresenting. Okay, so this table is a subset of the data collected. So these are quite a few of the tasks. These are the data sets, the baseline models that have been tested, and their metrics. They've only reported a few of them. They haven't reported every single one because although this is a lexical similarity metrics. But yeah, I mean, there are kind of these leaderboards, but it's probably not worth getting fixated on them because the idea is that it's multi-dimensional, the output for any particular model. Okay, so that's kind of the results of it basically. Okay, so let's have a look. So carrying on, complex interactions between the sometimes contradicting measures. We thus will not distill the complex interplay of the data, metrics, and model outputs into a single number or statement, and we do not present results in a traditional leaderboard. Instead, we developed an interactive result exploration system that allows analysis of model results, and which we describe in this section. To further motivate this change, consider the following conclusions someone may draw from looking at the leaderboard. Yeah, so that's the interface we saw earlier on, the one where you could kind of select a model and a day and then see all the different metrics on it. So they're saying this statement, system food performs the best, might have been what you would have said if there was a single leaderboard. But in this approach, this is the sort of thing. So our interactive system aims to enable more nuanced statements such as, so now you would say, system food leads to consistent performance increases in bar type metrics. On challenges, they measure BAS while maintaining equal performance on most metrics of type Q. So it's kind of a slightly more nuanced one, because your system is not going to perform fantastic on every single metric, but you can say what it's doing the best on, and what it's equal to performs on most metrics. Yeah. Sorry, you were going to say something. So yeah. So they say a screenshot of our system is presented in figure 2. So that's earlier on. Yeah, so the idea is that instead of saying, oh, the XY system is the best, now you've got to say XY system performs really well on these type metrics, but only kind of like maintains its performance on these type metrics, because not every any one system is not going to perform on every single one. Well, not for a while anyway. So yeah, so it's interesting. They're saying now the conversation has to be more nuanced. It can't be as simple as it was in the past. And this is a little description of the system. So our interactive system is centered around a parallel coordinate plot, which shows all results as lines through parallel axes. Every line intersects the axis of the corresponding mapped value. For instance, see the red line representing the results for total. Yeah, this is what we saw earlier on. And they've got all the different metrics displayed. But these are the same ones, but on the diversity metrics instead. Yeah, so there's a little bit of a detailed description of the, what that user interface is saw, but it's a little bit convoluted. I don't think it's worth reading it. I think we got the idea from looking at that. So yeah, so the next steps. So they've got this notion of challenge sets. So the idea is that, okay, fine, we've got these data sets, these 11 that we've already described in this paper. But the idea is that every now and then they'll come out with a test set. And it's kind of like a random entry into the set to kind of just, try its models on something they've not seen before. And they call these guys the challenge sets. And then they've got a notion that once a year, they will kind of reevaluate the data sets, take some out, put some new ones in. Yeah, this kind of challenge set is quite interesting in that the systems are not going to have seen this before. And it's a way to get some information on data that your system has not seen. Human evaluation, they're going to continue to iterate on the human evaluation to make sure it's reproducible and consistent. So there's going to be some research on that aspect. They'll cite a few papers on how that may be done. More multilingual data. Yeah, currently it's still heavily English-based, but obviously they're increasing more, multilingualness in it already. But yeah, they're going to try and get more multilingual data. So this is quite interesting. So personalizing NLG, and this is something I'm quite interested in. It says GEM currently focuses on tasks that deterministically transform an input into an output. With the increasing use of NLG models in real-world applications, how to enable and evaluate personalized NLG systems, for example, in dialect or formality, remains challenging. Several related tasks have been proposed, for example, the transfer of writing style from informal to formal, personalization of machine translation systems to align with particular personal traits, or persona-guided response generation of dialogue system. We envision our framework to be extended, for example, dataset evaluation to incorporate this line of user-centric analysis. So yeah, I've been meaning to read this paper, the 2008, because I'm quite interested in persona-guided response generation. So yeah, so currently there are no data sets in this where any of this really important stuff for real-world applications would be useful. But this is something they will incorporate, hopefully, fairly soon. I don't know if you had any kind of comment on that aspect of it.
Yeah, interesting. It's looks like a good effort on connecting research community with actually real-world problems. Because one of the main, I think, problems right now is that it's not really synergic, I would say, what is happening in this area. On the other hand, I think both Google and Facebook, they do a lot of production in their models and really using text models in the wild. So probably inside these companies, there are a lot of results which might not be published, as they publish these research results but probably do not publish so much these applications.
Yep.
Results in applications. I think it just has more of value in it, like commercial, and maybe.
No, you're totally right, because I'm sure there are many people commercially working on these systems, because this is a this is going to be a very significant market in the years to come. Chatbots, personalized chatbots. All sorts of personalization of many things. So yeah, cool. I think I'm going to stop there. There's nothing really critical beyond that. It's just kind of just a little bit of information about the authors and how they split the groups up. So I'm going to stop there and give you a chance, because I've been talking for quite a lot of time.
Yeah, sure.
So if I stop sharing,
paper, I would say it's good to have this. Good to have idea of what's going on there.
Yeah, I mean, it's not a technical paper, but it's good that how people are thinking, how things are going to be evaluated, what data sets are kind of people are going to be working on. It was interesting.
I think it's good to mix all those kind of different papers and to.
Yeah, cool.
So this one is more technical one, and this DBERTA is another variant of BERT, and there are a lot of these variants, like another pre-trained model for natural language understanding, and this one is quite interesting because they have really smart innovations, I would say. And let's just move to the. So the introduction is mostly introducing the concepts. So you probably know quite a lot about BERT and what it does and how it's trained. And I think we can skip over to the really their results. So what this probably it was noting what DBERTA stand what acronyms. It's decoding enhanced BERT with disentangled attention, and this small A in the end basically is probably the most important letter here. So what they introduce, they propose to change attention to be not to be in a for example in all the transformer models usually how positional information is transferred. We have word or token embeddings and positional embeddings. We sum it in the very beginning of the of the model, the first layer, and then we just process it through the bunch of this multi-head attention layers and positional feed-forward layers. And we have this skip connections for each model. And basically, positional information usually can be routed through these skip connections. That's why this is one of the reasons why skip connections are so important in transformers. And what this paper proposes is just we can move away from this approach and to use so what do they say? We represent position using two vectors, hi, like not position, but token and position. They are represented by two vectors, different. Hi is this hidden representation of the token, and Pij is a representation of the relative position information. And so they use this relative position. Each entry of this Pij matrix would be corresponding to the encoding of like relative position of two tokens. And basically you can, in this case, you can formulate total attention given here by Aij, which is attention from query I to like keys of J. So it would be sum of Hi, like this term corresponds to like standard attention, which we usually have, and then we have three like additional terms. But this here, what is different to like classic transformer implementations, this H matrices, they do not contain any positional information, but all the positional information is stored in this P matrices, and then we like compute two query to position key information and like keys to positional queries attention, and all these three components are summed together. And the first term is position to position, but actually they don't use it in in the final model, so it's not important really. It's position to position bit. So the attention weight of a word pair can be computed as a sum of 4 attention scores using disentangled matrices on their contents and positions as content to content, content to position, position to content, and position to position. And here they say we use a relative positional embedding. The position to position term does not provide much additional information and is removed. That's what I said about this. First term is not used in the final calculation. And yeah, here they describe like this is classic attention. We have queries, keys, and values, and we compute attention as a dot product of queries and keys scaled by the dimension, square root of dimension, and then we multiply that by values, and this is how we get the final attention score. And in their case, they do it for this content to content attention, but they have additional bits, which is, so this delta ij is a function which returns offset of like query to key offset, and it's 0 for if like token is minus k tokens away. So we attend in this span from like minus k to plus k tokens far from the token in focus. And this is just, it shows that they return 0 for all tokens which are far away, and k-1 for all tokens which are far away but in front of the tokens in focus. And for all other tokens, we have this offset. This is I is the position of like token for which we calculate the representation, and j is like the position of token to which we attend to, and this k is added to make it be between 0 and 2k minus 1. So, and then they compute a separate set of queries. So this QC, QK, all this this is like content queries and keys and values, and also they compute positional like query vectors and key vectors. These are computed from this P matrix, which represents relative position. And then these three scores are summed and used to compute the final attention matrix. And then like in a regular way, we just do this weighted sum over value matrix. So yeah, that's basically the main probably innovation.
Yeah, it's interesting. There's a guy on LinkedIn. He was complaining about like models, that the positional information was so hidden that probably the whole model was behaving like a bag of words, so that it couldn't distinguish. So this is interesting that the position is now being a lot more important in the model than it was in the original bit.
Yeah, yeah, it's like they give like much like direct route for positional information to be transferred through the model. So yeah, and in classic transformers, basically all the positional information just travels through these skip connections. And also because sometimes, like in most cases, we also apply layer normalization. It might be harder to learn for these models because like layer normalization, basically what it does, it might be like viewed as somehow equivalent to weighted sum over the vectors, like, and the weights are like variance. And so the ones with higher variance would be like would get more weight, and that's why there are some like modification which move all around this layer norm bit. And yeah, it's really interesting that they decided to do it a completely different way. And yeah, actually, it's really interesting that you can basically, well, like really, we used it before because, for example, the decoder attention, you can attend to the encoder output and attend to some, say, memory, stored memory. And basically, you can just treat this positional information as another embeddings, right?
Yeah,
so
yeah.
That's really interesting what they did, but also it's when you like read about it, it's also quite surprising why nobody did it before. Actually,
yeah.
So they describe this algorithm here, and basically it just describes what was said before. But yeah, they mention here that because these are relative positional information, we don't really need to store like this order n squared matrices for like we do not need like positional keys and queries for each content query to be computed separately. We can just do well with this matrix of size 2k by d, and yeah, it makes sense because like we learn like a single positional information, matrix, like embedding, right? And we can just then reuse it for all the content queries and keys. And here they describe how do you do that. So here it's described in like this with for loops in pseudocode, but actually in the code implementation they do it in batched manner. So that would be just batch matrix multiplication.
Yeah.
So, and it's like you iterate over all content queries and multiply it by this relative position key matrix, and you do the same for like content keys and relative position queries, and that's how you compute this content to position and position to content attention scores. Yeah, so actually, and in the end, you just index into this matrices with relevant offsets and get the scores you need.
So, what kind of evaluation have they done on this approach too?
So just another like technical bit. So they they say here that we have two extensions, which one is to address the limitation of the relative position, which have been fully captured by the disentangled attention. The other one to enable generation task and multitask learning objective. So they say that, for example, given a sentence, a new store opened near the new mall with the words store and mall masked for prediction, only using the relative position is hard for the model to distinguish store and mall in the sentence, since both of them are right after the word new in the exact relative position. To address this limitation, we propose to reconsider the introduction of absolute position in the model as a complement to the relative position. And there are at least two ways to introduce the absolute positions. In BERT, the BERT module incorporates the absolute position in the input layer. In the BERT, we propose an alternative to consider it right after the transformer layers, but right before the softmax for masked token decoding. So they add the absolute positional information right before you do the token decoding, which is basically like generating the tokens from the, like, it's in the very last layers of the model. And we call this new approach enhanced masked decoder, EMD, and I think they will use it this abbreviation sometime. So I wanted to, and also they mentioned here that they used both like this masked training objective, but also they tried it with natural language generation. It's like GPT style text generation, when you mask all the afterwards coming tokens. So they have some information here on how it's done, and basically what they claim here is that their model is outperforming all the other variants by some margin on all of the tasks they evaluated on, and it's outperforming BERT, Albert, Roberta, ExcelNet, and this Megatron models on a bunch of tasks. Here they have this MNLI task, this Squad V1, Squad V2, and other like tasks usually used for fine-tuning like this NARIS name entity recognition and I don't know, this SWAG, I don't remember what is that, but those are all like regular kind of fine-tuning task. And they measure the model performance on that. And also they surpassed human performance on superglue benchmark. This is the first model to do that. And I checked it some time before, and I think there was another one which performed even better, but it was probably some like ensemble models, some ensemble model. And yeah, they study bunch of, they do a bunch of ablations. They demonstrate how removing this enhanced mask decoder impacts the performance. And this removing this content to position attention, position to content attention, and other things. Yeah, and they also show that their model is training like faster, much faster. So here, red is their implementation of Roberta. And you can see that it really like consistently outperforms with like starting with a small number of steps, and it keeps this margin of performance over Roberta on this squad task.
Yeah, cool. So,
and also they trained a bigger one. I think this is the one which beat human on this superglue benchmark. And they also, here they say that we share the projection matrices of relative position embeddings and content projection matrices. So it seems like you can really learn a single matrix to project from the like relative position information to keys and queries, and the same to project from content to keys and queries, which is quite interesting and a bit strange. They have some tables that shows that the performance is mostly identical. Also, they have some like bunch of other interesting technical details. They add a convolutional layer aside with the first transformer layer to induce and gram knowledge of subword encodings, and their outputs are summed up before feeding to the next transformer layer. So they add this convolutional layer together, and it's like complementary to the first transformer layer. So it's like they do this first round of encoding in this in two ways and sum over. Also, they note here that they used this scale invariant fine tuning algorithm, which what it does, it regularized so that given a task-specific example, the model produces the same output distribution as it produces on the adversarial perturbation of that example. So basically, there is like this fine-tuning modification, which ensures that the fine-tuning results on the downstream task are consistent when you do this adversarial perturbation of the input. And yeah, it's interesting to have a look at that, because maybe like, you know, it's one of the problems to like avoid this catastrophic forgetting when you do fine tuning on some smaller data set for downstream task. And yeah, I will look in more details on to this scale invariant fine tuning and how do they use it to improve this fine-tuning performance. Yeah, and they claim that it improves the performance substantially. So yeah, and here they have, I think this is their results on superglue. And yeah, here you can see that the average score is higher than human average score. And they outperform T5 with 11 billion parameters, and their model used 1.5 billion parameters. So it's like about 8 times smaller, right? But it outperforms T5 on most of the tasks. And there are only two tasks where T5 outperforms this DBERTA.
Cool.
And yeah, so, and really great like progress made on this. I remember we read this superglue paper sometime before, and this superglue benchmark was introduced because the previous glue one was considered to be really easy, and their original BERT was really by performing worse than human by a big margin. But now this with this changes, actually again the models beat human on this this task. That's quite interesting.
Yeah.
Also, there are still some tasks where you see, and this what would it be? I think this is Vinograd schema, right? Task. And here human have 100 accuracy, and language models still cannot do the 100 on
the. A lot of kind of real world knowledge for Vinograd schema. So yeah, physics, kind of how the world kind of works in terms of objects and people and places and how they interact. So yeah, Vinograd schema is really, really difficult. But it's still interesting that it does 94.9, because when Vinograd schema was first started, I think most models were only doing just over 50, 54, 55. So huge progress.
The questions there are, I think they are like fairly easy for human, right? So it does not require like a deep knowledge, it's just common knowledge. And
that's right. Yeah. They're very, very simple questions about statements as to whether something or other, what it's referring to. And yeah, for a human, they're really pretty trivial. Although, mind you, they're not all trivial. Although it's interesting, it's 100%, because I tried a few of them, and it depends on how you parse the sentence, you see, because it's all to do with. So I guess you'd have to be somebody who's really, really good at English. And really versed in it, but yeah, I'm surprised the humans got 100%, because I know the sentences are not complicated.
Yeah, I think this
the two alternatives are not
two of three, right? So it might not be that human always right on this, but like regularly two humans of three are correct. Right?
Okay. It's been a while. I mean, I remember looking at the Vinograd schema questions. Yeah, that makes sense. Because I didn't get all of them right, and I was like, man. But this is really brilliant. This is a really fantastic paper, actually.
And they have a great appendix. There are a bunch of things here that might be interesting. Like, for example, they say that for fine-tuning, they have better and robust results using R-Adam, which is rectified Adam. It's a variant of Adam which I would say regularizes early performance or early training of the model, and they found that it results in better. It has better results when fine-tuning on downstream tasks, on some tasks, but for the evaluation, they used Adam to be like consistent with other models. And another thing they mentioned here, that they explore attention patterns. And here is for DiBerta, the strip appears in the first column, which represents the CLS token. And we conjecture that a dominant emphasis on the CLS token is desirable for a good pre-trained model, since the vector of this token is often used as a contextual representation of the entire input sequence in downstream task. So basically, how I interpret this, that DiBerta learns to encode like the whole sequence information in this CLS token better compared to like Roberta. Yeah, they compared to it to Roberta. And here, like one can see that for Roberta, there is like this strong diagonal matrix, diagonal of the matrix, but for DiBerta, it's not really there.
Yeah.
And yeah, so the token learn to attend like more diversely, it seems. And it because like in the, basically what it means is that Roberta attends more on like self-attention is stronger in Roberta because it needs to pass this positional information through self, right? But in DiBerta, they don't have this problem, and because positional information is transduced separately and transferred separately, and that's why it does not attend to, like, self-attention is not so strong. So basically this like kind of liberates the model, right?
Yeah.
Allows it to attend more sparsely, like not sparsely, but more widely. Yeah. So that's interesting. And yeah, that's all. And also this, basically what is their encoder? This scheme makes it like more interesting. So what they do, they in the last, they have this last layer, and it can be repeated. And here is this content information provided, and as queries they use this. In their case, they use the positional encodings. And this is how the information is used. So basically, we use only the absolute positional information as queries for this last layer, and it learns to combine these values according to their keys from their absolute position in the text for decoding. So that's interesting. And what they also note here, that basically you can input here any information you want in the end. And this allows like maybe to do some experiments with really control the generation, right?
Yeah.
So that's also interesting, but they did not do any like other variants of that. They only used it to provide this absolute positional information, but you can experiment with that. And also they draw that this acts like may act to like be repeated n times. So you can like share a weight, but do this a couple of rounds of computation here. And in their implementation, they did 2 rounds here to improve it. Yeah. So quite a number of interesting innovations. And I have checked the code, and it's quite comprehensive, and they published all the code. It's in PyTorch, and the model is available in Hugging Face models. So maybe I will try to compare it on some downstream tasks with like regular BERT and maybe Roberta, and see how if it's really easy to get some better results by just swapping BERT or Roberta or whatever you use by tBERTA.
Does Hugging Face have this included at the moment? Let's have a look.
Yeah, Hugging Face have a couple of these models published already.
Oh, fantastic.
Yeah, and it's quite recent, so it's cool how fast it was done.
Yeah, brilliant. Yeah, great. Yeah, I mean, if you find out about the code, exactly how it works, I mean, I'd love to find out more. But this is, yeah, this is really fantastic. As I said, this paper is just amazing. It's got so many interesting things in it. Things that, you know, I mean, I didn't know how to do it, but like the positional encoding, as I say, when I first saw it, I was like, it was a miracle it was working in the first place, the way it was just added on to the token. So yeah, really fantastic. Great, thanks.
Yeah, and that's interesting because like this relative positional information, some parts there are like skipped. They have right now in their repo the v2 dBERTA, and it has this like you know, you can bucketize the relative position and attempt like do it more fine-grained for closer tokens, and do like really long-range attention with bucketizing the far-away tokens, and they have it now in their repo. So it's like a bunch of like perspectives for this to be improved even further, I think.
Brilliant. So yeah, that was really great. Thank you. Yeah, I haven't decided what I'm going to do next week, because I want to implement this reinforcement learning, but I don't know how long that's going to take. That might take a week or two. I might choose some other simple paper. And if you've got any ideas and papers that you want to have a look at, that would be, you know, I'll be more than happy, you know, to do that. So yeah, if you have any suggestions for papers that you want to do, that would be great. But yeah, best
I don't
case,
have like suggestion right now. I might like probably during the week I will maybe I will be working on some part of something and find interesting paper which would be related to that, and then I will like post it.
Yeah, great. Yeah, so as I say, I'm going to try and focus hopefully maybe this Saturday and next Saturday, and trying to get that reinforcement learning into PyTorch, and see if I can get it working, because the data they're using is not like the full pre-trained models, so I should be able to do it in Uncolab. So yeah, great.
There is another paper on application of reinforcement learning to NLP, which I found. It was they applied reinforcement learning for style transfer, and
Fantastic.
Yeah, so I haven't read that paper yet, but basically it just like framework for training the model.
Okay, fantastic. Yeah, I don't know if you can put the reference to that in the chat. Sure. And then, yeah, I'll have a look at it, because I'm quite interested in style transfer. I mean, the paper we did it must be a month or two back, and that was really interesting as well. I've got it on the backlog of things I want to implement. But yeah, this reinforcement one, I quite liked the output it was generating. So I was like, yeah, I definitely want to play with this one. So yeah.
Yeah, that's interesting, and it's good to find some motivating example to try this reinforcement learning.
Yeah. Cool. Okay. Well, this was this was really great, Elton. Thank you for that. And yeah, I learned a lot. Obviously, you know, a lot of stuff that I would need to learn, but yeah, brilliant. I've got a reasonably good idea of how Debata now works.
Yeah, okay, see you next time.
Yep, hopefully, yeah, probably next week now. But yeah, great.